Welcome. This video will review available run parameters within the STREAMLINE automated machine learning tool, as well as their default values. We'll cover these run parameters grouped as follows: essential run parameters, general run parameters, data processing parameters from phase 1, imputation and scaling parameters from phase 2, feature importance estimation parameters from phase 3, feature selection parameters from phase 4, modeling parameters from phase 5, post-analysis parameters from phase 6, additional parameters between phases 7 and 9, and other run parameters. Of note, parameter names within STREAMLINE can differ slightly between run modes, specifically depending on whether STREAMLINE is being run within a notebook or the command line using either configuration file or command line arguments. For this review, we'll mostly be using run parameter names as defined for configuration file use. You can check out the link at the bottom of this page for detailed STREAMLINE documentation covering all run parameters and their names for each run mode. We'll start by discussing some run mode considerations with respect to run parameters. When running STREAMLINE from one of the included notebooks, either Google Colab or Jupyter Notebook, run parameters across all phases are pre-specified before running the pipeline in its entirety. When running STREAMLINE from the command line interface using a configuration file, run parameters are similarly all pre-specified before running the pipeline in its entirety. And when running STREAMLINE from the command line without a configuration file, for example running one phase of STREAMLINE at a time, run parameters are specified as command line arguments for each respective phase. Now we'll discuss essential run parameters of STREAMLINE, which all users need to consider when running STREAMLINE on anything other than the included demonstration data. First, we'll cover parameters dealing with folders and files, names, and paths. Dataset path is the run parameter that specifies the path to the folder containing one or more target datasets to be analyzed. Output path is the run parameter that specifies the path to a folder where the STREAMLINE output files will be saved in what we'll refer to as the experiment folder. Experiment name is the run parameter defining a unique name for the current STREAMLINE experiment output folder that will be created at the output path. Rep data path is the run parameter that specifies the folder containing one or more replication datasets to be evaluated using previously trained models for a specific target dataset. Dataset for rep is the run parameter that specifies the path to the file of the individual target dataset used to train the models, which you want to evaluate with the above replication dataset or sets. Moving on to run parameters dealing with column names in the dataset, class label defines the name of the class or outcome column found in the dataset header. Instance label defines the name of the instance ID column that may or may not be in the dataset header. Match label is the name of the match or group ID column that can be included in the dataset to keep instances with the same match label together within the same cross-validation partition. Moving on to run parameters that control the specification of feature types as either categorical or quantitative, we have both categorical feature path and quantitative feature path. These parameters allow users to pass a file or a list of feature names to be treated as one feature type or the other. If a user specifies a list of feature names for just one of these run parameters, STREAMLINE will assume that all other features should be treated as the opposite feature type. Moving on to other essential run parameters, the ignore features path run parameter is an optional convenience for the user that specifies a file or list of feature names that STREAMLINE should remove and ignore from the target datasets for the purposes of the analysis. Other essential run parameters that are specific to command line interface run modes include a set of Boolean flags that turn on or off different phases of the pipeline. DoTillReport is a flag indicating that all phases should be run, excluding phase 8 replication and the part of phase 9 that creates a report for replication analysis. The following 7 parameter flags allow the user to specify a subset of the phases to be run if DoToReport is false. These include doEDA to run phase 1, doDataPrep to run phase 2, doFeatureImp to run phase 3, doFeatCell to run phase 4, doModel to run phase 5, doStats to run phase 6, and doCompareDataset to run phase 7. Further, the doReport flag runs the phase 9 summary report, which pairs with having run phases 1 through 7. DoReplicate is the flag that runs phase 8 replication, which also requires phases 1 through 7 to have been run. DoRepReport is the flag that runs Phase 9 summary report generation specific to Phase 8 replication analysis. And do cleanup is the flag that optionally allows users to run a quick cleanup of temporary files generated in the Streamline output experiment folder to save space. Moving on to general run parameters, CV partitions is the run parameter that defines K, the number of K-fold cross-validation training and testing set partitions to create and apply throughout the pipeline. A default of 3 partitions is used in the demo, but an eternal default of 10 partitions is built into Streamline more broadly. Partition method is the run parameter that defines the cross-validation strategy to be used, which has a default setting of stratified partitioning and the options of stratified, random, or group partitioning. Categorical cutoff is the run parameter used in the automatic discrimination of categorical versus quantitative features. Specifically, this cutoff is the number of unique values observed for a given feature in a target dataset, after which a variable is automatically considered to be quantitative. This parameter has a default value of 10, but will likely need to be updated to be successful for different datasets. SIG cutoff is the run parameter defining the statistical significance cutoff used throughout the pipeline. It's used in deciding whether to run pairwise non-parametric statistical comparisons following group comparisons, and for identifying significant results. Its default is set at 0.05. Random state is the run parameter that sets a specific random seed for the Streamline run. This is important for pipeline reproducibility. Notably, to ensure Streamline reproducibility, especially when running Streamline on an HPC cluster, the timeout hyperparameter sweep run parameter, discussed later, must also be set to none. Moving on to Phase 1 data processing run parameters, exclude EDA output allows users to exclude some of the outputs automatically generated by Streamline during Phase 1, mainly to simplify the output and reduce the required output storage space. This parameter's default is none, meaning that all outputs will be generated by default. As options for this parameter, the user can specify describe, which indicates that Streamline shouldn't run or output the set of standard pandas functions, describe, data types, and number of unique. Also, univariate plots, which indicates that Streamline shouldn't output individual univariate analysis plots illustrating features versus outcome. By default, Streamline outputs these plots for any feature with a significant univariate association, which further relies on the SIG cutoff run parameter. And third, correlation plots, which indicates that Streamline shouldn't output feature correlation heat maps for either the initial or processed data exploratory analysis. Another run parameter is top uni features, which defines the number of most significant features to report in the notebook and PDF summary. This is set to a default of 20. Feature eng missingness defines the proportion of missing values within a feature above which a new binary categorical feature is generated that indicates if the value of an instance was missing or not. Its default is 0.5. Cleaning missingness defines the proportion of missing values within a given feature or instance at which the given feature or instance will be automatically cleaned from the processed target dataset. Its default value is also 0.5. Correlation removal threshold defines the Pearson feature correlation at which one out of a pair of features is randomly removed from the processed target dataset. The default here is 1, defining perfect positive or negative correlation between features. Moving on to Phase 2 imputation and scaling run parameters, impute data indicates whether or not to apply missing data imputation to features in the data. This parameter is true by default. Multi-impute indicates whether or not to apply multiple imputation using scikit-learn's iterative imputer for imputing missing values in quantitative features. If set to false, then median imputation will be used for quantitative features. Mode imputation is always currently applied for categorical features. This parameter is true by default as well. Scale data indicates whether or not to apply standard scaling to features in the data. Again, this parameter is true by default. And overwrite CV, which indicates whether or not to overwrite the Phase 1 version of cross-validation training and testing datasets with newly imputed and scaled cross-validation datasets. Ultimately, this parameter allows users to keep versions of the CV datasets after different phases of pipeline processing, rather than just the final version. This parameter is true by default, meaning that only the final processed CV datasets will be saved within the Streamline output. Moving on to Phase 3 Feature Importance Estimation run parameters, do mutual info indicates whether or not to run mutual information as a feature importance estimation algorithm prior to modeling. Its default is true. Do multisurf indicates whether or not to run multisurf as a feature importance estimation algorithm prior to modeling, and its default is also true. Use turf indicates whether or not to run a turf wrapper algorithm that operates around multisurf, improving its ability to detect feature interactions in data with a larger number of features. This option is set to false by default. Turf PCT is a parameter that currently serves two functions with respect to the turf algorithm. First, it determines the proportion of instances that are removed from consideration during a given turf iteration. And second, it dictates the number of turf iterations, where the number of iterations is defined by 1 over turf PCT. Its default value is 0.5, meaning that half of all features will be removed over the course of 2 iterations. In contrast, if this parameter was set to 0.2, 20% of features would be removed each iteration over the course of 5 iterations. Instance subset defines the number of randomly chosen instances in the training dataset to be used for running multisurf, with the default of 2,000 instances. This is useful in datasets with a very large number of instances, since relief-based algorithms such as multisurf scale quadratically with the number of instances, making it run extremely slowly on datasets with a very high number of instances. And lastly, njobs defines the number of CPU cores dedicated to running multisurf with a default of 1. Moving on to Phase 4 Feature Selection run parameters, filter poor features indicates whether or not to apply feature selection to the dataset, having a default value of true. If set to false, no features will be removed from any of the training or testing sets prior to modeling. Max features to keep indicates the maximum number of top-scoring features to retain in cross-validation datasets prior to Phase 5 modeling. Selection is based on the scores of the feature importance estimation algorithms that were run, including mutual information and multisurf. By default, this parameter is set to 2,000 features. Export scores indicates whether or not to export bar plots for the feature importance estimation algorithms mutual information and multisurf. These bar plots summarize average feature importance scores over all CV partitions. This parameter is true by default. Top FI features specifies the number of top-scoring features based on the mean over cross-validation runs to illustrate in the above feature importance estimation bar plots, assuming export scores is set to true. By default, 40 features are displayed in these plots. Overwrite CV feat indicates whether or not to overwrite the Phase 2 version of cross-validation training and testing datasets with newly feature-selected cross-validation datasets. This is similar to the parameter previously described for Phase 2. Its value is true by default. Moving on to Phase 5 modeling run parameters, algorithms is used to specify which machine learning modeling algorithms will be applied. When this parameter is set to none, it tells Streamline to run all modeling algorithms by default. Here we have a list of 16 scikit-compatible machine learning modeling algorithms currently available within Streamline. The abbreviated names in parentheses are used in this run parameter to specify that algorithm should be run. Related to the algorithm's run parameter is the exclude run parameter, allowing users to specify which machine learning algorithms to exclude from analysis, meaning that overall by default, Streamline will run 14 machine learning algorithms, with the exception of ELCS and XCS. Further, training subsample is a run parameter that defines the number of randomly chosen instances in the training data to be used for training certain longer running algorithms. This is set to 0 by default, indicating that all instances should be used in training. This run parameter impacts the following set of machine learning algorithms within Streamline. UseInformFI indicates whether or not to override any available modeling algorithm-specific model feature importance estimation methods, instead using scikit-learn's permutation importance estimator uniformly across all algorithms. This is set to true by default. Export hypersweep plots indicates whether or not to generate an Optuna plot visualizing the hyperparameter sweep of an algorithm on a given dataset. This parameter is false by default. Model resubmit is a parameter specific to using Streamline within a command line interface. and is a Boolean flag that tells STREAMLINE that this is a secondary run attempt of Phase 5 modeling. This can be useful if a given algorithm run failed to complete and the user wishes to rerun unfinished modeling without rerunning the entire pipeline from scratch. This parameter is false by default. Primary metric defines the evaluation metric to be used to optimize hyperparameters and is set to balanced accuracy by default. Generally speaking, we recommend users apply balanced accuracy, ROC area under the curve, or F1 score in this parameter, based on their needs and priorities. However, this parameter is set up to use any metric identifier described at the following scikit-learn link. Metric direction indicates whether the primary metric should be maximized or minimized during hyperparameter optimization, and this is set to a default of maximize to pair with balanced accuracy. N-trials is an Optuna parameter controlling the number of hyperparameter optimization trials to be conducted in the hyperparameter sweep. This is set to a default of 200 trials. Timeout is another Optuna parameter controlling the total number of seconds until a given hyperparameter sweep stops running new trials, and this is set to a default of 900 seconds or 15 minutes. The last modeling run parameters we'll discuss are specific to learning classifier system algorithms available in STREAMLINE, specifically ELCS, XCS, and extracts. Do LCS sweep indicates whether or not to apply an Optuna hyperparameter sweep to any of the learning classifier system algorithms. Since these algorithms are generally computationally expensive, but have fairly reliable default run parameters, this parameter is set to false by default. LCS-NU specifies the NU parameter used by LCS algorithms that controls the pressure imposed on the algorithm to identify an accurate solution. This is set to 1 by default, but for problems where it is known that a perfect prediction model is possible to be obtained, in other words, a dataset with no noise, this parameter can be set to higher values, for example 5 or 10. This, for example, would be useful in applying learning classifier system algorithms to clean problems such as the multiplexer problem. LCS iterations specifies the number of learning iterations that an LCS algorithm will run. This is set to 200,000 by default and can be increased or decreased based on the size of the dataset or the expected complexity of the underlying problem. LCS-N specifies the maximum rule population size for an LCS algorithm. This is set to 2,000 by default, but again can be increased or decreased based on the size of the dataset or the expected complexity of the underlying problem. And lastly, LCS timeout, which is similar to the earlier timeout parameter. This parameter controls the total number of seconds until an LCS algorithm hyperparameter sweep stops running new trials. LCS uses this separate run parameter since it can take a lot longer to run an LCS hyperparameter sweep than for other machine learning algorithms. Its default is currently set to 1200. Moving on to Phase 6 post-analysis run parameters, exclude plots allows users to exclude some of the outputs automatically generated during STREAMLINE Phase 6 post-analysis. This is set to none by default, meaning all outputs will be generated. However, the user can specify plot ROC to avoid generating ROC plots individually for each algorithm that includes all CV results and averages. Or they can specify plot PRC to avoid generating PRC plots individually in the same way. Or plot FI box to avoid outputting model feature importance box plots for each algorithm. Or plot metric box plots to avoid outputting evaluation metric box plots for each metric comparing algorithm performance. The metric weight run parameter defines the evaluation metric used to weigh model feature importance estimates when generating the composite feature importance plots. Its default is to use balanced accuracy. And top model FI features specifies the number of top scoring features based on model feature importance estimates to illustrate in feature importance figures, including feature importance box plots and composite feature importance plots. Its default is set to 40 features. Moving on to run parameters used in phases 7 through 9, Phase 7 dataset comparison currently has no run parameters. Phase 8 replication run parameters include exclude rep plots, which allows users to exclude some of the outputs automatically generated by STREAMLINE during Phase 8 replication. This is set to none by default, meaning that all outputs will be automatically generated. However, users can again decide to exclude feature correlation heat maps for the replication datasets during replication EDA, as well as ROC plots individually generated for each algorithm, and similarly PRC plots, and metric box plots. Phase 9, controlling summary report generation, also currently has no run parameters. Lastly, we'll cover some other non-essential run parameters. First, Streamline includes some optional cleanup parameters. Del time is a Boolean flag telling Streamline to delete individual runtime files from the output experiment folder, set to true by default. Del old CV is a Boolean flag telling Streamline to delete intermediary cross-validation datasets from the output folder. In other words, training and testing datasets that were generated prior to completing data processing, imputation, scaling, and feature selection. This is set to true by default as well. Streamline also includes some logging parameters. Verbose is a Boolean flag telling Streamline to send all print output and warnings to the command line output. This is set to false by default. And logging level is a Boolean flag telling Streamline what logging level to use in the command line output. This is set to info by default. And finally, we have some multiprocessing parameters. Run parallel indicates whether or not to run Streamline in parallel locally using CPU core multiprocessing. This is set to false by default. Run cluster indicates whether Streamline will be run on a DAS-compatible computing cluster or HPC. Setting this to false indicates that Streamline is to be run locally, while it can also be set to run on any of these other DAS-compatible computing cluster options that may be available to the user. The run parameter reserved memory is important when running Streamline on an HPC and indicates the memory in gigabytes reserved for Streamline jobs. This is set with a default of 4 gigabytes. And queue, another important HPC run parameter, indicates the specific queue within your HPC where your Streamline jobs will be scheduled to run. The name of this queue will be specific to your computing environment. Again, for any further details, check out this link going into Streamline run parameters in even greater depth. Thanks for listening to this review of Streamline run parameter options. Please feel free to reach out if you're interested in collaborating or if you have any questions.